Hey, my name is Nick. I think I've met several of you so far at the conference, but I am an astronomer slash software developer at the Space Telescope Science Institute. Um, I want to kind of back up from the previous two talks, which sort of started from a really great scientific use case, and they developed some really great packages to work with it, and do it sort of from the other way where spectroscopy has been happening for a long time in the astronomy domain, and we've kind of been tasked recently with the advent of new telescopes to kind of impose some sort of standard with how spectroscopy tools interface with each other and interface with requirements and things like that. So I kind of want to go through a couple packages that we're developing at Space Telescope and highlight some of the lessons we've learned and sort of give an overview of some of the stuff that we have found is really necessary for good community engagement and good software development. So just to go over some of the packages that I want to talk about, SpecUtils obviously is a big one. It's an AstroPy package, which I'm sure you've heard about, but it's undergone a recent sort of renaissance. Version 0.3 has been soft released. We're working on getting it onto PyPy once I figure out who owns the PyPy login information. But its primary tour de force is the analysis capabilities and data handling. So great. Its usage is great for things like handling uncertainties or bit flags or masks or anything like that in your spectral data, and doing any sorts of analysis over that data. The next thing is SpecVis, which is a visualization software. Very interactive, very GUI focused, very much sit down and mess around with your mouse and stuff and look at it and make it pretty and do your analysis that way. It's built on top of SpecUtils, so there's nothing really special aside from the actual interaction and visualization stuff that's built in. The last thing that I want to talk about, and unlike the other two packages, is extremely new and is just now kind of coalescing out of discussions and conversations, is this small package called Cosmoscope, which deals with multi-source distributed communication, which is meant to tackle the issue of people's workflows being different in the sense that you can have maybe a mid-career older astronomer who is not very good with code, especially Python, maybe have done everything in IDL or MATLAB or something, who may really like SpecVis because it's just a GUI and they can just load in their data and do all the stuff they want, versus the astronomer who is more code-centric, who wants to sit down at their favorite CLI or an IPython notebook or something and just hack away at their code and maybe pop open SpecVis to do something quick and then go back to their code and just sort of have everything together. This Cosmoscope package sort of deals with that issue of being able to communicate across different front ends, interacting with a common back end. And I'll talk more about it later. But to back up a bit, this is something that was touched on yesterday by Carl. The biggest thing that we found in developing these spectroscopy packages is the ability to get it in the hands of users, especially scientists, people who need to use it immediately, or especially instrument teams who are testing their data products. In this case, I just want to iterate over using these predefined package templates for Python packages. The AstroPy one is excellent. We use it for SpecVis and SpecUtils, and it's a really great way to get built-in docs and unit testing right off the ground immediately. Another one we like to use is the cookie-cutter PyPackage template, which is very similar to the AstroPy one, but comes with a couple more built-in services like PyUp integration, which basically is a third-party service that looks at your requirements for your package. And anytime one of those requirements get updated, it will do a pull request on your repo saying, hey, this requirement's been updated. Let me run all your regression tests and see if it'll work, and then you can accept it if everything passes. It also comes with a cool integration with bump version, which means that every time you publish a release on GitHub, it'll push it up to PyPI automatically without you having to do anything. So very useful. The other big issue that gave us lots of headaches early on was distributions. SpecVis, being a UI program, uses the Qt platform or framework, and that's just basically a whole bunch of C++ classes wrapped in Python, which generally requires a user to compile it all on their system to use it. Since SpecVis was Python 2, Python 3 compatible, we needed a way to distribute binaries with this pre-compiled binaries so that users weren't banging their head against a wall trying to compile C++ code on their computer. So Anaconda was great for that. It allowed us to distribute binaries, both for Python 2 and Python 3 packages. And we liked it so much that Space Telescope created the Astroconda channel, which is now housing all of the packages we create at Space Telescope for really easy distribution and environment management. Now, the Python package index is your typical pip install platform. And the problem with this was that it was very Python package centric. So for all the C++ stuff we needed, it wasn't great because Python 2, using Python 2, there's no binary distribution through pip, basically. It wasn't until Python 3 and the new form of PyPI that they allowed this wheel format binary to be distributed. However, we do, going forward, for any package that's been Python 3 oriented, we have been doing distribution through both PyPI and Anaconda, which has helped immensely with users of every level of code experience. Our lesson 2 that we found out very early was listening and empowering users to contribute and to be active in the development of these tools. So like I said, this is a little different from the previous talks in that we didn't have a particular science use case that we were building this tool for and opening it up to the community. We were sort of just applying standards and rules from top down. So it was very important that we be aware that we are pretty much invading scientists' spaces in terms of their nominal stacks that they use to do their own science and spectral analysis. So what we've done, obviously, is open up, our Git issues, Slack channel, mailing lists, things like that to get people involved. But one of the biggest things that we found worked well is to have these hands-on feature sprints and hack days where we invite scientists or even people with no coding experience but who have very specific science use cases for spectral analysis or spectral visualization to come and sit in on the sprint with us or the hack day and sort of pair up with developers to ensure that their workflow or whatever segment of their workflow they need to have emulated in these new spectroscopic tools are properly being introduced and developed in a way that they could then use it immediately with their own science. One of the obvious cases here that I've accentuated is on the left we have a Confluence page from the Hubble STIS team describing a lot of the IRAF tasks that they deal with on a regular basis and that they are really interested in moving over into Python. And in this case, we are using SpecUtils to sort of house this. SpecUtils and SpecUreduce are two packages that we're developing for the spectroscopic analysis stuff. And here, by the end of the sprint, we had a preliminary version of the splice functionality from IRAF and a preliminary version of a spectral collection object to deal with a shell spectral data built into SpecUtils. And what was great about this is we had scientists on board immediately who looked over our shoulders, made sure that we were doing it basically in the way that they were used to or in ways that they had their own checks and balances for, and they had experience with what to expect and the results that got out. And it was really easy then to make unit tests, regression tests to ensure that us developers who may not have experience in every domain of spectroscopy were getting the required knowledge in order to implement these features. Likewise, there's, sorry.
Those sprints thus far have all been had at Space Telescope?
Yeah, so most of the sprints are at Space Telescope. However, I'm sorry. She asked if the sprints had all been held at Space Telescope. The answer is yes, most of the sprints are held at Space Telescope. However, all of our sprints and tag-ups take place online, Skype and everything, and we regularly invite users and scientists from other observatories to sit in on the sprints and to communicate with us through our Slack channel and through the GitHub issues and to have them on board every day when we do our tag-ups during the sprints. So if anyone is ever interested in stepping in the sprints, yelling at us about poorly implemented features or having suggestions about how we can implement something cool for spectroscopy that's useful for your work case, we encourage you to join the Skype calls, join the Slack channel, everything like that, to be involved. But since predominantly the developers for these tools are housed at Space Telescope, we generally run the sprints at Space Telescope. The next lesson is that we found early on was don't try to replace someone's workflow wholesale. try to make the packages we develop usable in a piecemeal type of way. This is the sort of shining example here is we have a pretty nice, robust data loading and data writing infrastructure built into SpecUtils that allows users to create their own custom loaders and writers for their spectral data. And there's actually a couple groups at Space Telescope and at a couple other observatories who basically use SpecUtils only to parse their data from FITS files or from ASCII files, dump it into the Spectrum-1D container object, where it nicely sorts, uncertainties, bit flags, masks, and all that other stuff, and then they just rip all that stuff out and have it go on to the next stage of their pipeline. This is a great example of using the package piecemeal, where they're not, completely tethered into the ecosystem of SpecUtils, but they can still use it in a reasonable way that works for them. Likewise, for SpecVis, we are very aware of this whole walled garden thing where right now it's a very GUI-oriented program, so we tried to make it very easy to extract stuff out of the analysis you do in the SpecVis environment. So in this case here, I had fit a model to data. Oh, imagine that, an astronomer fitting models to data. And what I want to do is be able to use this model outside of SpecVis. So here I'm exporting this model as actual Python objects that I can then copy and paste and put into an IPython notebook or something like that after I had done all this nice fitting and stuff to my data. This way it makes it very easy to avoid being stuck inside the SpecVis UI interface and everything. Likewise, you can export it as a YAML file or some other descriptor so that you can share it or give it to colleagues or use it in some other fashion. And we've taken this same with the data layers and the other spectral operations that are performed in SpecVis. You can then do smoothing over a spectrum and then export that spectrum as another data file that you can then use in some other analysis that may not require SpecVis. So lesson 4, give users the tools they need to implement features they want, so you don't have to. This is pretty relevant for spectroscopy as a whole, since there seems to be many disparate kind of groups with very unique needs in the spectroscopic community. So here is a good example in SpecVis of the data loading wizard, which is a very simple way to load a file and interactively parse it, or teach SpecVis how to parse it by telling what's the dispersion, the data, the uncertainty, the bit mask. And then here it creates this YAML file which can be saved out and used in the future or in another analysis that doesn't require SpecVis. So in this way, we want to encourage users to kind of help themselves. And so this kind of takes this notion of being able to abstract behavior away from the actual core mechanics of SpecVis or SpecUtils into something that's manageable by users of sort of many levels of code competency. Another thing we wanted to do was compartmentalize feature development. So SpecVis is a great instance of this, where every feature of SpecVis is actually implemented as a separate plugin, which is very approachable even from a user perspective. So here on the right, I have just sort of the model fitting plugin that I used in the previous slide to develop that model. And really all it is a single module where I've subclassed this Python object called plugin, and that immediately gives me access to putting tools in the toolbar in the UI, making panels on the side of SpecVis. It plugs me into the SpecVis message system so I know what's happening in other parts of SpecVis. And a user can just kind of concentrate on this chunk without having to understand all the murky mechanics of the SpecVis ecosystem as a whole. And we found this was very good for getting users involved and giving them the ability and empowering them to make changes that they might need. Again, this is sort of from that top-down perspective where we don't want to step on people's toes because they have a particular workflow that's already working for them, and we really just want them to be able to interoperate with the stuff that we're building. So lesson 5 kind of goes back to the Cosmoscope package I'd alluded to earlier. Choice seems to be the biggest, our biggest block. Without a doubt. And so in this vein, we have tried to deal with this in several ways. One of the most oft-requested features is the ability to, like I mentioned before, start analysis in an IPython notebook, pop open SpecVis or some other spectroscopic package we're working on, do a bunch of analysis there, and go back and have everything already in your IPython notebook environment and just continue on. So Cosmoscope takes this to a next level and sort of creates this a little API server that exists that just kind of sends messages between itself, which can plug into some sort of set of spectroscopic functions, such as SpecUtils or something, and then just sort of messages out to any other connected client about what's being asked to do about the data. So this is an example here where I am just importing this decorator called reversible operation, and using it to wrap just a regular smooth data function. And you can see immediately that as soon as I evaluate this cell, it adds this to the server API. So now anything that calls into the server can use this as a function to get it and communicate out. Down here, I'm creating a basic client that just binds to this server address and allows me down here to have access directly to that smooth data function directly through this client object. So that was a little heavy, but in more of a schematic format, you can imagine it like this, where we have this server running and that has a connection to all of our analysis functions. And say I start from a shell script or a shell client or something, and I do an operation like smooth my data. I send the data and information about the operation to the server. It does whatever it wants to do to the data, and then it propagates messages out to any other connected clients to that server. So you can imagine having SpecVis open, a regular GUI desktop application, with your IPython notebook, doing things and evaluating cells in your IPython notebook, and having them immediately propagate to some sort of visualization software like SpecVis. What's also interesting is we can, I've gone ahead and implemented a preliminary sort of form of a web client. This is using the Electron package, but you can imagine it could just be a web service somewhere, using Plotly. So Plotly is a great plotting package, as mentioned in the previous talk. And so we can get sort of the same functionality where this client plugs into the server, and as long as it knows the API, it can just call functions and receive messages that were happening across different front ends. So I'm out of time here, so I just kind of want to wrap up by saying we've just released version 0.5 of SpecVis, includes some cool, the ability to load in line lists and have them display on your spectral graph and things like that, marking and all that cool stuff with your spectral visualization. And of course, we have SpecUtils out and will be available on PyPy soon. So with that, I guess I'll just ask for any questions.
Quick comment on that last part. It turns out I have the PyPy access rights, and I just gave them to
Eric.
you. I just gave them to you, so that will probably be done by
Excellent.
the end of the week.
Cool, awesome.
Thanks very much. This looks really interesting. When you were describing your philosophy whereby you develop in such a way you can just cherry pick bits and pieces out, or users can integrate them into their own workflows. Have you had any feedback or discussions with users who do that about them sort of reinventing or not finding all the different features that you have because it is so kind of like cherry picked? So they just find one thing and then rewrite another thing that's available elsewhere. Do you have that issue?
Yeah, so it's generally not the case that they cherry pick something and then they rip out whatever they need and then they continue on and write new code to go with it. Generally, it's they already have a whole suite of code that they're fine with, but there's just one part that's really upsetting for them. It's, in the example I gave, it's just parsing data where it's just really hectic and they don't want to deal with it. So they take that out of their regular pipeline and just kind of like plug in the SpecUtils functionality, and it works and meshes well with the rest of their pipeline, which already might have, for instance, equivalent with calculations, running on just raw data instead of using the SpecUtils equivalent with functionality or something like that, just as an example. We generally don't push it too much for them to change their entire pipeline because that's their prerogative if they want to use what they've known has worked well for them for however long. But we do try to make it obvious in the documentation that all these things are available and connected to the core functionality. So we do try to make sure that users are aware of all of the stuff that they can do, but also aware that they don't necessarily have to use all of it if they don't want to.
I just want to add a comment as a recent reader of the documentation that I think there's a lot that can be done with the documentation. If this is something you're interested in doing, it may be where I'm spending a lot of my hack day is trying to make more examples of the things that I was trying to do that I couldn't figure out from the examples of how to do.
Yes, that's a really, really great point. This is just a couple of the packages we're developing, but overall, we have a huge suite of packages that we develop at Space Telescope, and we rely heavily on the community for fleshing out particular areas of the documentation or fleshing out particular features that are sort of beyond the scope that we had carved out for a particular feature sprint or something. So definitely, I encourage you to check it out. If you run into issues, file the issues. You know, make a pull request if you want to get involved. Anything like that, definitely take the initiative.
All right, I think we're out of time for questions, so let's thank our speaker again.